Hello and welcome back to the channel. For my Twitch viewers, thanks for hanging out with me today. Yesterday was quite a long video. Today shouldn't be as long. Should be a little bit shorter. We're definitely going to do the through-hole soldering on the board, touch up anything that needs to be touched up. And we'll see how much time. Maybe start some of the bench testing. I got some things kind of sussed out with the cameras. I tested my new phone, and it's powerful enough to be able to be used as a camera to work with OBS without doing the flickering. So I'll kind of be able to do some setup with that. And for my other workbench, I got to get a couple more ring lights and a couple other things. But, you know, we'll do what we can, the best we can with what we have for now. This is an adaptive learning process, and we'll get there. We'll eventually get there, I hope. So if you've been enjoying the channel, enjoying what we've been doing, enjoying following along, definitely on YouTube, like, follow, subscribe. Hit that bell icon to be notified when we push new videos up to YouTube. We really appreciate it. This has been a lot of fun. And let's just set unrealistic goals and just be crazy with it. And let's just shoot for 1 million subscribers by the end of this year. You know what? Strange things can happen, and why not? Let's just go for it. Come on. Let's shoot for the sky. Let's aim for the moon. Let's do it. So I've got my test plan here because some of the things will be, functional requirements, basically just kind of visual, as kind of defined in the test plan. So let's go up to here. Again, we're going to kind of clean this up. Basically visual verification only, but we'll do that after we assemble it because we want to look at everything as if it was fully assembled. So let me go over to not that one, my bad. Getting used to my multi-camera setups now and OBS Studio to be able to handle switching between all of them. So let me kind of get this guy a little bit better set up. I'm sorry if it makes anybody motion sick. I'm trying not to. This light jig is a little bit different. So I'm thinking what I might do over the course of, time is just kind of design and 3D print some better holding jigs. Why in the world are you losing focus? Okay. Goofy camera. Stop losing focus. My little cat wants to say hi. I got to do everything I can to keep him off of the workbench. So, not much ado. I've got the board right here. Maybe if anything, we will get the fan assembly maybe put together at the workbench. Who knows? We'll see what we can do. What we've got going on. So one of the things we need to do is, I noticed that the solder joints on the two buttons and the TVS diode were a little bit pasty, for lack of a better term. So basically what that means is the solder paste didn't completely reflow. These ovens that you can get off Amazon, they're great for getting into it, but they have cold spots, dead spots in them, to where you're not going to reflow properly. What I would like to do is get a nice desktop reflow oven that actually has a conveyor and a couple of extra zones. Neoden makes one. Nice little bench top. It would force me to redo my workshop layout, which I'd be more than happy to do to accommodate that, but we'll go from there. So we have a bunch of stuff to get into. So as I showed you yesterday, this is a flux pen. Well, flux dispensing pen. Basically got a fancy little paintbrush like little tip right there. I currently use water soluble flux. It's the easiest to clean up. So I have a little container with water in it that I can dip in, and paintbrushes that have been trimmed down to be kind of different rigidness to kind of brush and use the water with. Buttons typically don't like water. but I've found with these guys, they seem to be pretty tolerant of a little bit of water, but we're going to minimize and do everything we can to keep water from infiltrating them. Let me grab my towel. Okay, so I have a towel piece I will use to help dry things off. The ESP32, I wouldn't really wash too much either without a proper drying device, like a little oven or something. So I've got an old toaster oven. I'm thinking about converting over to like a drying oven, controlling it with an ESP32 to regulate the temperature and have a timing function and everything else. So we will grab, I even use solder that has wire solder that is water soluble flux as well. My trusty soldering iron. So let's get into it. Dab a little bit of flux. Don't ever be afraid to use flux. Flux is your best friend. And basically we're just gonna just touch up these solder joints and add new solder and cause the paste that was applied to actually melt and flow properly. So with a magnifying lens, I'll just kind of check. Again, I need to figure out some stuff to maybe get some magnifying for the viewers. I've got a desktop microscope that I think I can interface via USB. I'll have to play around with that. If I can use that along with OBS Studio and get the image there, you know what? That'd be freaking cool. And I could share better things with you. So maybe that's what we'll do. Maybe I'll try to get that set up by tomorrow night's stream and give you some better details of some of this stuff. So maybe you could see more of what I see. So you could see more of what I'm trying to get at. So the TVS diode looks good. So now I'm just going to go on to do the push buttons. Actually, the flux is more what I'm concerned about doing harm to the switches than the water, to be honest. Oh, I don't like that. Hopefully that didn't... Nothing looks like it shorted out. I don't like the fact that I got solder up on the switch. I didn't come in low enough, but that's fine. I'll test it out here in a minute. Once I get it kind of cleaned off, get the flux off of it. Let's see what we got here. Flux on this side and get. Again, I'm doing everything I can to keep everything in frame, but that's kind of difficult. All right. So one precaution I want to put out there that I kind of forgot about, failed to mention, is like everything else, safety is important. You are working with high heat with a soldering iron. I currently solder at 680 degrees Celsius. You'll have a lot of people tell you, oh, that's too hot, that's too hot. No, professional experience has told me no, you need to go hot for most things, because especially if you have a multi-layer board. This is a 6-layer board with a power plane and a ground plane in it. This thing will pull heat away from your soldering. The main objective with soldering is to you're fighting entropy. You need to get the joint hot enough and the board hot enough to actually accept solder. So through experiments and experience working in the industry, you have to go hotter than a lot of people recommend, and to actually get things to solder properly. So yeah, I push my iron at 680 degrees Celsius. So one of the things I do want to let you know is obviously it's hot. That's hot enough to cause second degree, third degree burns, and that is something you do not want. So keep that in mind. You're also working with chemicals and solvents here. Flux is not pleasant. It is a chemical and it can be toxic. So ensure you wash your hands after doing this type of work. If you smoke or vape, try not to vape or smoke until you've washed your hands. Now I'm using lead-free solder, but some places don't have easy access to lead-free. So definitely make sure you wash your hands prior to smoking or vaping, because or eating or anything. So basically you want to avoid contact with any part of your human body with your hand, your fingers or anything until after you've washed them after soldering. You could use no clean flux and a cleaner for it, because there is an IPC standard on how much flux to leave behind, that you can leave behind. So just keep that in mind. All right, so that looks dry enough. Does the button still actuate? Yeah. Nice satisfying clicks. We got the solder off. Cover up my water. I don't want to accidentally spill it over my bench. So yeah, safety. Keep safety in mind. Safety glasses. That's the last thing you want. So I've got the 4-pin connectors. I need 1, 2, 3 for the board. Oh, that's one too many. I can't count. Put these guys aside. I'll grab the 3-pin. I only need one of them for the RS-45. Put those aside. And now the 2-pin. 2-circuit. Alright. Okay. Now, kind of move some stuff out of the way. Try not to have too much crowding out the frame. I'm trying not to. So we have our 3, 4 pins, the motor, then your inputs, the 3-pin for the RS-45, and the 2-pin for your power. So let's go ahead and start getting this stuff populated. Oh yeah, like a glove. So what I tend to do is put the component in and kind of push it in one direction. In this case, I'm pushing it towards the edge of the PCB. I'm going to grab my flux pen. And we're just going to grab a little bit of solder on the tip. And we're just going to kind of tack one of the pins down. That way it kind of holds it in place. We'll go through and do the same to the other connectors. Yeah, I might have to try to pull this out a little bit. Pull the camera out a little bit. I'm trying, like I said, I'm trying to keep everything on frame, but that's difficult. Okay. You don't have to worry about soldering it 100% at this point. That's basically just to tack it into place to hold it while you get the next one in place. Now, something you could always do long term, if you're going to be doing this by hand a lot, is you could design a jig for it, really, that hold the connectors, like 3D print something, hold the connectors, and you just plop the board down on it, and you could rapid solder everything that way. So there's all kinds of ways you could do this. For actual production, you'd probably want to use a wave reflow machine, a wave soldering machine. and or a selective soldering unit. Those are kind of close. Hopefully, I don't think they're too close. Because the courtyard was cleared, so it should be enough distance apart. So again, I'm just tacking everything in place. So I can just come through here and rapid fire. Solder everything up, all these guys at once. Let's see, that's the positive. All right, good. All right. That big capacitor. All right. So, I've got all of them tacked into place. The one that's going to be the most troublesome is the power connector because the ground connection is tied to the big heavy ground plane. So let's get these guys all tied into place real quick. Dance around the tack one first. Do it last. All right. Again, I have to figure out how to get better, like, zooming and stuff. We'll work on that. And another thing I'm going to mention is if you're new to soldering and stuff, I don't know how well you can see this, but avoid conical tips. People love them. A lot of soldering irons ship with them by default. I'm going to be flat out honest, they suck. The only thing they're really good for is burning yourself, burning holes through plastic, and maybe wood burning. For actual electronic soldering, they suck. Because the round shape does not allow efficient heat transfer from the tip to the joint in question. Because the shape, it just doesn't allow it. The whole goal is to transfer heat as quickly and efficiently as possible so you can get the soldering done without overheating the board or the component. Because if you get too much solder or too much heat into the board, you can start delaminating it, which means you can start lifting pads. You can start separating the individual layers because it's just an epoxy resin that holds it all together. And you don't want that. So basically, you want to be in and out. Get the soldering job done. Be hot enough to overcome entropy of thermal mass. Big thermal mass parts like D-packs, things like that, and the entropy of your board. Now we're going to do the ground stakes, the stakes on the USB-C connector. Let's get them done before we accidentally rip that guy off. I like Gold Enig because it solders really well. It's just your boards are typically a little bit more expensive with it. But I prefer to do Gold Enig. Like I said, soldering is really nice with it. Okay, might have to hold the heat here a little bit longer on these ground stakes. We need it to get the flow upwards and towards the top. Kind of get that going, get that done. Now, as much as I like water-soluble flux, I do have to say that okay, that should be good enough to help keep that USB-C connector from getting yoinked off the board. All right, so that's those guys. With water-soluble flux, you want to make sure you clean it regularly, or clean it as completely as possible, because if you don't, it will linger on the board and it could corrode your components quicker. 1, 2, 3, 6. 1, 2, 3, 4, 6. All right, so we got the breakaway headers for the debug interface. Oh, I need 2, so that's right, not 6. I'm not working with a pick here. I only need one 6-pin. Yeah, getting burned is the name of the game, man. At some point, it's just something that you do. You're going to get burned when you're working with this stuff. That's right. Finally. All right. So honestly, if you get in this kind of work, get used to getting burned. I don't know why I tried to solder the ground connection first. That was kind of dumb. All right, tack those guys down. And then another thing you want to keep in mind is if your soldering is going to sit for more than like 5 minutes, 5-10 minutes while you're doing other things, tin the tip with a little bit of solder. That'll extend the life of the tip because the way the corrosion will work. So you always want to try to keep your tips tinned when they're just sitting there heating up. All right. So far we've touched up the pasty solder joints. We've got the ground stakes tied in there. We've got the connectors. That guy's a little crooked, but wow. Let's see if I can kind of reheat and rotate a little bit. I don't like that. That's a little too crooked for me. That's a little straighter. Okay, so that's all that done. Now we have really the test points. We got the breakaway headers. Those guys are in there. It's a little crooked, but I don't care. For a test board. All right, that's good. So now I do want to populate the test points, and those are going to be fun, but not too difficult. All right, because if these are anything like the last batch that I did, they kind of hold themselves in place. And they're so light, they're just not going to fall out on their own. How you want to orient them is up to you. I'm trying to figure out what would be the best orientation for these guys. Almost doesn't matter. They might be too close together. That'll be something we'll have to solve and check. Oop, that won't go in upside down. All right. So just kind of populating them all, kind of. Now, there are also test points that you can get that are just surface mount only, which are kind of cool. And they're basically just a pad. I like the through hole. It gives me the option to like solder wires instead of these little test points, but I love these little test points. they're, they're an added cost, and I get that, but you really can't beat proper test points, especially in the early development phase. Again, I should have thrown test points in on the stepper motor, and the fan and stuff, and the temperature sensor. I should have, and maybe we'll address that if we have to do a board spin. We might address that if we do a version. We might just go ahead and throw it in there and version it, but we'll see. We'll see what kind of results we get. But because I want this to be a dev board, having the test points in there might be worth it. And that's another reason the board's a little bit bigger than it could be, is because of the test points. I want to make sure there's room for them. We could shrink the board size down considerably by not having them, but and putting more stuff on the bottom side of the board. A lot of these caps and resistors could have gone to the bottom side. But again, sometimes shrinking boards down to the smallest possible size looks cool, sounds cool, but it's not always necessary. Sometimes I don't see a reason to do something just to do it, just to flex, to be cool. If there's no absolute reason you have to build small, don't do it. Don't punish yourself. I want this board to be usable, approachable. So we might have to extend the size just a little bit, depending on how hard these test points are to access with grabbers and stuff. But they shouldn't be too terribly bad. I've got grabbers that should hold on to these guys. And once they're soldered and properly put into place. Again, this solder has flux core. Let's get the iron nice and so I don't really need to add any. All right, come on. Come on. Now, mind you, this lead-free, the RoHS level components and, flux and chemicals and stuff, they'll stink a lot worse. And the fumes can be annoying. So if you want, you can get on Amazon, look for one of those fume extractors, one of those little desktop soldering. That's a little stubborn because that's a ground plane. That way you don't have to worry about the stench or anything. But we're almost done. Zipping right through these guys. All right. Should we get the solder on the tip? Again, trying to keep everything in frame as much as possible, but sometimes it's hard to do that and focus on what I'm doing at the same time. So we got all the joints soldered. Let's grab our rag again so we don't make a mess. Let's clean up our solder here. Let's pull that back in. Grab our water. Okay. The paintbrush is a lot more gentle. They do make brushes specifically for PCB work. You can buy those. They're a little bit more expensive, or you can just buy a pack of cheap paintbrushes and use them. You don't need anything fancy. You don't need to use special water or anything. You don't have to use distilled water. The big thing is just make sure everything's as dry as possible. So it's a mistaken notion that you can't get electronics wet. That only applies, one, if you leave them wet, you don't want them to stay wet. Two, if there's power applied. So if someone's got like a backup battery or something, you want to make sure, like a RTC battery, you want to make sure that's pulled, so you don't short anything out. Yeah, you're going to lose your time and date, maybe some other stuff, but yeah, no, you can get it wet. Again, the biggest thing is to not let it stay wet and not to have power applied. But other than that, most electronics are perfectly fine having water on them. So I've got this other brush, which is a little bit more rigid. This other paintbrush, so it's good to buy a mixed set. Oh, I got it. Oh. Okay, so in my Twitch chat, I've got a visitor. Hey, good. How are you? Thanks for jumping in the stream. Hope you're enjoying what we're doing. Again, I'm trying to keep monitoring the chat and the stream, but it's difficult, especially with my workstation set up in my office or the workshop. But yeah, glad you're here. Thanks for joining us. Trying to get this soldering leveled out, and we're actually almost done. Getting this board now cleaned up. So yeah, this brush is a little bit more rigid, so it has a little bit more scrubbing power to get some of that burnt flux off. Again, that's not a violation. It's not necessarily a problem with the board. It won't, but IPC doesn't like it. So, okay, so I see a couple of solder joints I want to kind of touch up a little bit. Again, once I get my microscope set up and tested, see if I can actually do what I think I can do with it, I can be able to show you better stuff moving forward. Okay, so this PCB, for the new visitors to the stream and the channel, if you haven't been following along, so this PCB uses an ESP32. So an ESP32. It's going to be a dev board interface to drive a stepper motor using Texas Instruments DRV8825 stepper motor driver chip. It's going to have a couple opto-isolated inputs for control signals like limit switches, on-off buttons, stop-start buttons, whatever you want to basically program it to do. I've seen there's nothing really like this on the market, and I got tired of throwing these circuits together on breadboards. I wanted a dev kit. It can be used for automation. You'll be able to use it for anything. So everything's right now technically open source. I mean, while I still maintain intellectual property rights, and I will actually sell finished boards that will have my logo, my company's logo on them, the Magic Forge. But all the files are available through GitHub. You can download, yes, I'm using optocouplers. So that's what these guys are. They're optocouplers for the control inputs. Because it's going to be set up for typical automation environments, 24 volts. These are 24 or 12, so you'll be able to run 12, but the goal is 24 volts because most automation equipment is set up for 24 volt logic and signaling and everything. Those are AC optocouplers, so you could technically use an AC input source, a 24 volt AC source, and they'll still function. And polarity really doesn't matter. So we have a common on there that you'll be able to have positive or negative. And I've got a jumper put on that way you can use the integrated ground into the board if you want to use that as your common source. I wanted something to be versatile so it can interface with the PLC, and that's actually something that we're going to be doing kind of for one of the production tests. Is I'm going to be throwing together a click PLC program probably on stream. I'm not 100% familiar with the Click PLCs, and we're going to be writing a test script, test program using a Click PLC, and a discrete input-output control module for it. So we'll be doing all that. So this full video series, we're up to what, episode 42 so far on the stream, at least. Electronics in Ohio, I mean, we're due to the economy and the tariffs, things have honestly slowed down a little bit. Oh, I see a jumper I forgot to install. The termination jumper. The jobs aren't too high in Ohio, pretty much. You might be better off looking more out west. The tariffs are making it a little bit difficult to bring manufacturing back. They're actually counterintuitive and working against us in some regards, because a lot of the equipment needed to produce the products come from overseas too. So you have to pay tariffs on the equipment to build the products that would build more equipment in the long run, and it's just a vicious cycle of not gonna work right. I just don't understand that logic. So yeah, Ohio's not the greatest for electronics jobs. There's a couple of companies, but a couple of them are actually closing their doors, scaling back their operation. I've been seeing open to work profiles show up on my LinkedIn, so that's not a good thing from some of the local companies. So that's not a good sign. So, one part I forgot I missed was the jumper to enable the termination for the RS-45. So that's another thing this board will have. Yeah, I can imagine. Yeah, I've heard some foreign countries have some issues with their manufacturing because of the way their governments operate. Yeah, I'll see if I can get my LinkedIn profile linked through in Twitch. You can also find us, the Magic Forge, on YouTube as well. I think I've got a link there. But yeah, I'll get all my socials and everything all kind of updated and stuff, so people can find me and what we do a little bit easier. If you're more curious about what we do, the Magic Forge, and what I do professionally. So the Magic Forge, what I'm doing here is a side gig because I do electronics as a hobby as well as professionally. So I am full-time employed as an electrical engineer, doing pretty much the same stuff I'm doing here on screen. Designing electronic PCBs and layout and everything else. Yeah, so I'm just kind of cleaning up. So what happens is you kind of get these stalagmites that form off of solder joints. I don't like them because that creates a little sharp area and you don't want to poke yourself with that. So I just like try to clean those up where I can when I see them. Grab my towel again so I can clean this PCB, clean the flux off. That. All right, so we got that. Close my water up. Actually, I'm going to get like a little dispenser for the water eventually. Put my flux pen away. My cleaning brushes away because I think we're done with them. All right. So idealistically, so then what we do is we take a like a 10x magnifying lens and just help us kind of visually inspect. Like I said, I need to get some better stuff set up. Turn my soldering iron off. I don't need to. I think we're all done soldering. Just kind of make sure that we are fully soldered with our solder joints. There's nothing really outstanding. A couple that might need touched up along road, but I'm not terribly worried about that at this stage. A couple test points, but you know, they're fine, they're functional. All right. So one of the things that I try to strive for, because I have had training in IPC 610A inspection for electronic assembly standards, is I shoot for class 2 with what I do. And there's some stuff with the standards, so a couple things I'm not really meeting 100% of the standards with. And they're just really hard to show on camera. But for a lot of your through-hole work that you can kind of see the plated through-hole and have access to. I don't know if I could show you that. It's bandit test point. But this 3-pin for the RS-45, on all of them, except for that one little pin, the ground pin, which is, go figure, that's where you're going to run into your problems, is I don't see the solder actually drawn up all the way through the plated through-hole pad. That technically is an IPC violation. Same thing with the ground stakes on the USB port. I'm going to go ahead and accept this. Not consider it a fail or anything, because this is a pilot board. And there's a good chance it won't work. So, you know, and that's the chance we take. So I'm going to turn off this light. Well, no, I'll leave it on. There ain't no big deal with it. And all right, I'm done with that. I'll grab this, this, and this from the bin. Where'd I put that copy? Okay, so I printed out the schematics best as I could, because we might be assembling the fan assembly today too. Come over to my other workbench and I'll get it set up camera wise. So bear with me a moment. Okay. Hope you can hear one of my cats calling in the background. All right. So let's see if I can get off of that guy, go to this guy, see. Huh. All right. Cool. Cool. So it's not zoomed as much. I can get a better holder for the phone to be able to kind of get closer to the workbench. So I'm hoping you can kind of see. So I've got the completed board here. Hopefully it's enough. I got the parts for the fan. If we get a chance to assemble it, it's already going on 240. Since I overran the video yesterday, went into 3 hours. I don't want to do that today to torture my viewers. So one of the things I also failed to do, I'm going to get done, is design the serial number sticker label. Get that thrown in and update it, and thrown in the project resources. Get at least one printed out for this board. And I'll kind of have like a quick work instruction written up for how do we generate the serial numbers. But for now, because I'll do is I'll get a serial number label for this board. And we'll kind of play catch up. I should have done that already, but that's my fault. That's what I get for not scripting and doing these videos properly. But you know, hey, that's the breaks. So I've got the board here. We can do some of the testing, and I'm going to flip off that webcam. And that's my new phone, so it's not flickering or doing the weird stuff that the other one was doing, my old phone was doing. Maybe I need to reset it, reinstall everything from scratch, and just have that app on there only. But we'll see. I don't mind using my new phone. It's a better phone anyway. So I'm going to switch back to my desktop. So we have this. So we have the functional requirements. No, I can't. So the functional requirements, these are just basically visual inspections, and then the test logs for it. So basically, we're going to double check, and does it meet those requirements. I'm also going to grab these pluggables. I forgot to grab my pack of jumpers. I'll grab that and deal with that later. Because even though we're not going to put the jumpers completely on the board, I'd like to have them with the board for later. So we're just going to kind of go back to the phone. And I can kind of glance over, see what we need to do. So one of the things I want to do is, for one thing, make sure those actually plug in, because that could be a failure. You just don't know sometimes, to be honest. I may end up having to buy some more of these pluggables, actual terminals, so we can build up our test fixture. I have enough, so I may not have to worry about that. And look at these guys. That guy plugs in a little tight with the control and the limit switches, but that's fine. Okay, perfect. Beautiful. So the way we would ship this board is, like I said, I failed to grab a pack of jumpers for our own internal purposes. I'm just using the ones I've saved from old hard drives and computer builds and stuff. And we'll just kind of place them just on just one of the posts. I'll have that set up for the next video stream, which will be tomorrow. Tomorrow evening is when we're actually going to do the bench testing. But right now, you know, so we've got our pluggables in there. So pluggable headers is one of the requirements. So yeah, so we got the pluggable headers. They go in. They're tight. They're not just going to fall out. So shipping it, I'd have the headers, the pluggables in there already. The jumpers just kind of sitting there, disabled basically. And then this would be in a nice static bag, and I'd have a packaging or something for it. I might actually do a box and see about finding a company to manufacture boxes. But I'll look more into it. I'll figure it out. Because I kind of want this to be a nice little product, like you find as a nice little product packaging. Maybe we'll do a static bag and maybe some like a box with like some ESD foam or something. We'll figure it all out. We'll see what we do. I mean, it might just be a static bag because cost will still factor in, because I still have to charge for those materials. So let's see here. Requirement: ESP32 module with Wi-Fi and BLE support. Yes, so this is the ESP32 module. It'll be set up so it can use like either one of the low-cost PCB antennas that you can get that just can sit in the enclosure, or something like an SMA bulkhead with an external antenna, depending on how you want to do it as the end customer, the end user. So we've got that. I'll just be using one of the little cheap PCB ones for any internal testing for, prototyping and stuff. One of the other things we want to do is design and 3D print an enclosure for this. Because we want to build a mount fan in it. So we're gonna have to do a whole bunch of different stuff. We'll figure it out. Maybe we'll solve that problem when we get there. So one of the other things too is hopefully my heat sinks come in tomorrow, and we can apply that. That way we can check those in. And do all that. So maybe tomorrow we'll kind of figure all that out, because my workshop computer is not my main office computer, so I have different things set up on them. Access I don't and do have. So we'll have to figure all that out. So let's see here, the ESP32, the driver chip right here for the stepper driver. So that's there. 1224 volt input. Here's the DC input. Yes, we've got it. Boom. Pluggable headers. That was a requirement, functional requirement. So yes, we have our pluggable headers, our pluggable header for FTDI interface. That's all there. USB programming interface, which is this guy. So yeah, that's present on the board. Test points for power rails, which are pretty much these guys right here. Your ground, 3 volt and 5 volt. And we have LEDs for LEDs for visual indication. We have at least your power and a status LED that will come off of this. We could have thrown in additional LEDs. to monitor the signaling off the optos. We could have. That may have just overcomplicated the design and the layout. That's fine. That's what these test points are for, is we can monitor those signals there. So as far as I could say that goes, is a win. Actually, one of the bench tests we could do, but again, we're already heading towards that first hour. So we're not going to do it. We'll just do all that stuff tomorrow because assembly took a little bit longer than I anticipated. We'll take care of the fan tomorrow and start doing some more of the testing. But the first obvious test that we can do is, let's go back to the this guy. So we could do pass here. Oh, there we go. And all right, and then technically that passed. The workmanship acceptable for IPC class 2. Other than a couple of soldered joints, but again, this is the initial pilot board. I'm not going to stress myself over it too terribly much. So this could be this test log. We'll figure out that. All right. Test draw. We'll wait for that. Test date. We might update that for tomorrow to finish out the testing because we have all these resistances to do, which will be quick and easy. We can bang that out real fast tomorrow. I would probably almost bang it out real fast now. 10 minutes. I don't know if 10 minutes would be enough time. Well, we can always give it a shot, maybe start. So basically, we're going to be checking between all the test points, the power test points and stuff between them and ground. So let's go ahead and kind of jump over to that. Let me grab my nice handheld meter. I like it better for this work. All right. So we need resistance. All right. Kind of try to get this kind of stuff out of the way so it's not too busy. Yeah, again, a lot of stuff going on here. All right. So these leads are probably getting a little worn out. All right. So the resistance. Okay. We're at under a megohm. There we go. Now we're climbing. So right now we're at 10K. We're greater than 5K. So again, basically, you have to give the capacitors a chance to charge. Basically, these big bulk capacitors on the output, they're going to charge, so it can take time to reach the resistance reading. So we're greater than 5K between 3V3 and ground. Now let's check 5 volts in ground. So it's dropping from megohm to k ohms, but that's again because you're charging those bulk capacitors up. But the good thing is we don't have a direct short right off the bat, and that's what we don't want. So that is that guy. Check between those guys. And then basically we're checking between all right. It'd probably be easier if I had everything in print in front of me. Because now we got to check between all this stuff and ground. So let's see here. TP7, which is ground for this guy. So TP7. So basically we're jumping between all these guys to make sure there's no direct short to ground. And so far there isn't. And then we're going between, all right. I should have printed this out here. Okay, between 4 and 5. So it don't really matter. We're here 4 and 5. So we want to make sure we're greater than 1K. But we're easily in the mega ohms. Again, I wasn't 100% sure what we would be. We're just kind of checking all these guys to make sure that nothing shorted out. Okay. Pushing through all of them. Okay. CN2 terminal 1. Which is this guy. Terminal 1 should be right here. B. Basically B to ground. A to ground. We check. Okay. Now I should have needed my jumper. That was a goofy mistake, so we'll have to kind of make sure we test that tomorrow, because we want to test the terminator resistance. I don't have one around, do I? Well, we are going to kind of, well, we're going to do something kind of crazy that should work. Nope. These aren't connected up there properly. All right. Yep, I'm going to need to find my jumpers. I can't believe I did that. Completely forgot about that, but we might be able to do. Just so I can test it. Alligator clips. Okay, why aren't you reading the 120 ohms there? All right, so we should be getting 120 ohms off this guy. 120 ohms. So with this jumper, A and B should have 120 ohms between them. All right. Got to double check, see what's going on here. I will have to figure that out. I will double check that and figure out why there's no, why the 120 ohms, maybe I'm just not grabbing that jumper right or something. So we'll figure that out. I'll figure that out tomorrow when I actually grab jumpers. I've had weirder things happen. All right, so ground. And then all the control and limit interfaces. Yep. Definitely greater than 5K. Basically just kind of go through them. Make sure nothing's shorted out. That's basically what we're trying to do. Again, so basically all this extra testing right here is to help make sure that say, hey, you know what? You know, you're okay to maybe build more boards if you have to. All right. So then it's getting close to 3 to the hour mark. And again, I don't want to overrun like we did with yesterday's video. So what I'm going to do is I'm going to call this quits today. That way also give me a chance to dig up my jumpers like a ninny. I completely didn't think about that. I'll grab my jumpers for those so we can fully test all of that. I might make it easier and try to print that out so I have a copy in front of me, so it's just a little bit easier. Because idealistically, you want a workstation for like technicians to be able to test this. They have a computer in front of them, easy access. That way they're not bouncing and jumping back and forth. Makes their lives easier. Because in a QMS environment, you want to refrain from printing documentation as much as possible. You'd rather keep everything digitally controlled and on the in your secure storage to reduce errors, and that way you ensure that your employees are using the latest documentation available. But for what we're doing, since I'm the only one here, I can kind of skirt past some of that and not have to worry about it. So, yep, we're going to stop here because we're already about an hour in. I thank you for checking us out, staying with us this long. I really appreciate it. We really appreciate, and we're really enjoying what we're doing. Really excited to be getting to this stage. Hopefully tomorrow we'll be at least powering this guy up and doing some of the initial tests, finishing out some of the resistance checks, and moving on from there. So thank you. You have a great rest of your afternoon, and hopefully see you tomorrow.